So I think the subject of today is, I mean, we're already familiar in this dialogue with this subject of today because we have turned around it a lot. It's about knowledge.
Knowledge.
Yeah, about knowledge. And when we are talking about knowledge, specifically in modernity, in this society that we are in today, we are thinking about objective knowledge. The idea that it's not a knowledge as long as it is not objective. So I'm wondering what could it mean? Because you have demonstrated in your work that you could have, when you have your omega number, it's an infinite number. So if you say that you know this number, it's like if you knew something infinite. And I'm wondering, how is that even possible that something infinite could be objective? Because objective could mean two things: the object itself, and an object has limits, so it's not infinite. And objective could mean also you have an objective like in a photograph. So you have an objective, so you're pointing out at something specific. But when it is infinite, are you pointing out at something specific in a certain direction? I mean, what do you think about that?
Well, there's also objective as opposed to subjective knowledge.
Yes.
Or, yeah, well, I guess the two big divides are empirically derived knowledge, right? Science.
Yes.
And then there's mathematical knowledge, which we mathematicians like to think is more solid, perhaps, than knowledge in an empirical science.
So you think it's more solid? It's weird to say it's more solid. Well, when we are talking about solidity, in fact, the only way we have to define it, it's through empirical experience. Like, oh, it's a solid, it's a liquid. No, I'm kidding, but it's interesting to say, no, it's more solid when it is mathematical. Well, you don't see anything.
But the world of math is a bit unreal, right? So how can it be more solid? But the work...
I will not say unreal. I don't think it is unreal. You remember we were saying that it is not unreal, but maybe it's far from our experience, what we are used to think is real.
Well, to a mathematician, Guicciardi, in his little book, A Mathematician's Apology, makes the point that if you look at a chair very closely, it looks less and less real, because it consists of atoms, and the atoms consist of electrons whirling around protons, and then you have quantum waves and the quantum theory, and the more you look at the chair, the more unreal it seems. Whereas he said, 2 + 3 is 5. That's it. Finished.
Over.
So, of course, since mathematicians spend their lives in this Platonic world of at least mathematical ideas, to them, that is more real than the physical world where almost anything can be contested, right? Do you believe in global warming? Is it provoked by industrialization and greenhouse gases? There's always, although, consensus emerges, but there's always dispute in real science.
But of course, because consensus,
about the facts.
Yeah, because consensus is born out of the fact that some people try to overcome their differences. So that doesn't mean that the differences don't exist, because it is born out of it. So it's still there. So it could rise again at any time.
Yeah, they could all be wrong. A consensus emerged. Certain views were, so to speak, suppressed, but they could be wrong. It could be that some of those views.
But I
consensus can be wrong, and it is whenever there's a paradigm shift in science. The consensus changes. And that's why there's so much resistance to a paradigm shift.
And the paradigm is just a consensus, actually.
Yeah, there's the sociology of science, plays actually, I think, a very big role. So that means that objective knowledge it's objective compared to subjective knowledge, which is even worse. They're all questions of degree, are they not?
But I'm wondering, because when you were saying, and I'm just trying to follow you here.
Yeah.
When you were saying that there is a difference between objective and subjective knowledge, you say the difference between objective and subjective knowledge, and you said also that there is empirical.
Math, I can make that point
You said there is empirical knowledge, and mathematics, and you distinguish mathematics as not being empirical, of course. So, do you mean that mathematics is actually subjective knowledge, because the other one, because the objective knowledge is the knowledge of the object, so the experience, so empirical, and therefore
math,
subjective knowledge, mathematics.
Math is this world that some of us think are a priori ideas. It's different from, I don't know, what did Kant call analytic versus a priori?
Analytical versus synthetic.
Synthetic.
For Kant, synthetic is actually what you call empirical knowledge. It's the fact that there is A, my subjectivity, there is B, the outside world, and in fact, we don't know what is the outside world for what it is, because there is always a distance from our subjectivity. But in the same time, we have our subjectivity. And so he said, the knowledge is always C, something that is not our pure subjectivity, because it would not exist if there wasn't something that did something to my subjectivity, right? And it has to have something there, but it is not the thing in itself, because it's just like the waves, the excitation or something. And so therefore it is C, so it's what he calls synthetic. And he said the problem is like, most people in common knowledge, they think it's analytical. So they think that when they think they have their subjectivity, and B is the world of object, and so it's like if they were taking the world of object, say, oh, look, that's object. No, it's not object. It's the wavelength of the light just going on. And so that's very interesting to say it's always C. It's never A, subjectivity. It's never B, the object. It's just C. You know?
Yeah, well, at any rate, I think as a question of sociology, there tends to be more of a consensus in mathematics whether something is correct or not. It's also a question of the community arriving at a consensus. There are mathematicians who claim to have demonstrated something, and the proof is very long and strange, and sometimes people can't understand it, and they don't feel it. Maybe it's worth it to take the trouble, depending on the reputation of the person who has announced this result. So there is a question of sociology of science, also in mathematics, community consensus, whether the result has been proved. But in theory, according to Hilbert, mathematics could be made completely objective rather than subjective. And his idea was by using what are called a formal axiomatic system. And what that means is that instead of using, German or French or English to write a mathematical proof, and then it's a matter of opinion, it's sort of subjective whether the proof is correct or not. Because you're using pronouns, different people may understand differently. How well was it written? The idea was you don't use normal language, you use a mathematical logic, you use an artificial language with very precise rules of grammar. And what Hilbert said is the rules of reasoning, the logical rules, should be so precise, also the axioms that you start from, your postulates. The idea was to make a formal axiomatic theory for all of math, and the rules would be so precise, I think the way he said it, it would be mechanical to decide if a proof is correct or not. It would not be a matter of opinion, that one referee thinks the proof is correct, another referee thinks the proof is wrong. One referee could still think the proof is important and should be published, and the other referee could say, this result is really not of any significant interest. That's still a matter of opinion. But whether the proof is correct or not, if Hilbert's program had worked, formalizing all of mathematics, it would eliminate some of this subjective element in math. So that was the idea of Hilbert's idea that mathematical truth is objective, and that we ought to look for a formal axiomatic theory, for a theory of everything, for all of math, that the whole community can agree on. And in principle, that would show that mathematical truth is objective. Now, in practice, you wouldn't use this formal system to write proofs, because the proofs end up being very long if a machine can check. There's actually been a lot of engineering work on that, and it's actually getting better. There are now proof checkers that can fill in the gaps. And there's been a lot of very good engineering work by some mathematicians on carrying out Hilbert's dream. And then they do formalize some pretty sophisticated proofs, and they run it through the checker. And this is actually starting to happen. Hilbert's dream is actually turning into a technology that some mathematicians like to use to check their results, for example, results that are questioned or, for some reason or another, it would be good to confirm, give an extra confirmation to. But in principle, Hilbert's program fails because Gödel already showed that there is no theory of everything for all of math. And Turing in another way showed it, and Omega shows it in yet another way. So with that...
Because the entire logical system can't prove itself.
Well, there are...
It can't prove itself. There is the inner and the outside.
Well, what happens is outside the system, this is meta-mathematics, outside the system, Gödel shows that there are mathematical results that mathematical assertions that you can't prove within the system, but you can make arguments outside the system that they're correct. So this means that your system is incomplete.
Yeah.
And this actually applies to any formal axiomatic theory, as Turing showed more deeply.
Yes, we are entering into Gödel.
Yeah, into Gödel and Turing.